Right, number 4. Oxidation -2 except -1. Alright? Right? So, example of compounds. So, if we look at I want to stay here in compounds, right? Because I don't want you to make mix up and say, oh, but what about oxygen gas, which is 0? But that's different. So you have to state in compounds, alright? So if we look at compound or ion, so oxygen, for example, if we look at magnesium oxide, look at sodium carbonate, look at H2O2, right? So just to note that oxidation state of oxygen here equal to -2, oxidation number, oxygen equal to -2, oxidation number in peroxide of oxygen is equal to -1. Alright? So as you can see, whether the compound is oxide as the mono ion or in carbonate, it's still -2. So the only exception for oxygen not being -2 is when it's in peroxide. Like hydrogen peroxide, it's gonna be it's -1.
Yeah,
right?
It's because the two atoms, it have two atoms, 2 hydrogen and 2 oxygen.
Yes.
That's to make it right.
Alright, so this structure here is like, even though this is not organic chemistry, but it's like this. Alright? It's a covalent compound, and it's like this. So you find out that this is +1, +1, this is -1, -1. You gotta remember that.
So shared.
Yes. Because what happens is that, remember that if it's a compound, the overall charge must be 0 for compounds. Only ions will have a charge. Alright? Alright, so moving on to rule number 5. So with the exception of oxygen and hydrogen, the oxidation number of elements in covalent compounds and polyatomic ion will vary. Alright? So number 5. SO2, SO3, right? So in this case, oxidation number of sulfur in this case will be equal to 4 plus 4. Oxidation number of oxygen equal to -2. In sulfur trioxide, oxidation number of sulfur in this case, which is the S, equal to +6. Oxidation number of oxygen equal to -2. I'll also discuss this in further details, alright? But I just want to show the example here that if you look at other elements, they might have oxidation number that will vary, unlike oxygen and
hydrogen.
and hydrogen. They will vary a lot. Alright, so this sulfur can be +4, it can be +6. Similar case we could use is carbon monoxide versus carbon dioxide. See? So in this case, oxidation number of carbon is equal to +2. Oxidation number of carbon in this case is equal to +4. Reason being, oxygen is always -2, except in peroxide. So it would simply mean that the next element would have to have variable oxidation state. That's what this rule is trying to say. So whenever you see like oxygen in a compound, it's always -2 if it's not peroxide. So if the next element must have variable oxidation state, can change. Alright? And this is two gases are examples that they can use to discuss that. Alright? So this is gas. Right? So this is sulfur dioxide, sulfur trioxide, carbon monoxide, carbon dioxide. Good? Oxidation state. So we have 2 more rules to go. Sum, alright, so this sum. So when you add them up, it should be equal to 0 if it is a compound. Following? Remember that you have compounds and you have ions different. Alright? Example. See what they use in the book. Example. Magnesium chloride. Alright? So in this case, magnesium is a group 2 metal, so the oxidation state +2 plus 2 here times the chloride is -1. It's a halogen, so halogens tend to be -1 when they are the anions. Alright? 0. Alright, so this is +2 plus, so this is plus, this is -2. Alright, so this is basically a +2 -2 equal to 0. That's why your maths class comes in handy. You see, you're learning these things in maths as well. Alright, so just to note that the sum, so when you add up the oxidation number for all the elements and ions in a compound, it must be equal to 0. That's why it's a compound. Overall charge is 0. Right? Alright. Moving on to the final rule. The sum of the oxidation number of all the atoms in a polyatomic ion is equal to the charge on the ion. Right? So both rules are very similar. One just referring to a compound, the next one referring to a polyatomic ion. Alright? Give you a chance. Finish? Final rule before moving to the question, right? The sum some examples like polyatomic ions. So you can have ammonium as a cation polyatomic. carbonate that we are used to, 2 minus. We are used to nitrate as well. And we are used to sulfate. We are familiar with these ions, right? This is ammonium ion. This is carbonate. This is nitrate. And this is sulfate. These are all polyatomic ions. Polyatomic ions, that's what we mean by that, alright? So it simply means that this is, so if for example, we know that hydrogen is always +1 except in metal hydrides, alright? So we know that the overall charge is +1, hydrogen is 4 times +1 plus the nitrogen. So we need to find the number for nitrogen, alright? These are the stuff that we're going to soon to work out, alright? As you can see, if this is 4 times +1 is +4 overall for the 4 hydrogens, then you can see that the nitrogen here must be -3. Following? Because the overall charge is +1, alright? So that's the case. So this is going to be -3 plus, so this is the nitrogen, hydrogen. Following? That's for the ammonium. For the carbonate, the overall charge here is going to be -2. The oxygen is always -2, so this is going to be 3 times -2 plus the carbon. But the carbon, so this is -6 here. So as you can see, for this to be -2, the carbon would have to be +4 for the carbon. This carbon, oxygen. But we are going to work properly now. Alright, so just take that from the board. I was just using it as the example. Alright? No, so the for the first one, BrO2. Alright, so bromine dioxide is a compound or an ion?
Compound, sorry.
So it's a compound and not a polyatomic ion, right? But BrO3 minus is a polyatomic anion. BrO2 minus O minus is a polyatomic anion as well. Alright? So remember that these are not popular ions that you need to know, but it's just to test the knowledge of calculating oxidation number, which you must have for the exam. Alright? So for this one, you can see that the rule that we're going to use for this one is oxygen is always -2, except because we want to calculate the oxidation number of bromine,
President, sir. So
which is Br.
the reduction part of this. Is there a calculation for the reduction as well, or is it just oxidation?
No, this is oxidation number, you know.
Yes, sir.
So oxidation number can be classified as oxidizing or reduction. You can remember that a decrease in oxidation number is reduction.
Yes,
And an increase in oxidation number is oxidation. But we'll soon get to those equations. First, I'm just teaching you to calculate oxidation number first. Because this is the basic part, you know. We have to move into the equation to calculate which oxidation number increase, which decrease, which is the oxidizing agent, which component or element is oxidized. Alright? We'll get there. But I just want you to know how to calculate these stuff first, using the rules. The 7 rules that I've just given, That's the principle we're trying to use here, right? And the rule that we're going to use is between the oxygen is always -2 except in peroxide, and the charge, overall charge of atoms in a compound is 0, while overall charge of atoms in a polyatomic ion is the charge and the ion. Those principles, 3 principles that we're going to use to calculate these, right? So they want to calculate the oxidation number of bromine, right? So it is, you can say X plus 2 times -2. Right, it's 2 oxygen, and oxygen is always -2. Following? So Williams, where am I heading, please? Green. Williams Green parts. Alright. Alright. BR2. When we have BrO2, this means that we have this O2 here is not oxygen gas. It means that we have 2O2 minus ions.